Hello and thank you for joining us. Welcome to our webinar, SovLabs 101. This webinar will discuss our ready-to-run modules, how to simplify your IT management, and how to optimize your VRA environment. It will also introduce OneFuse, our latest product, which is the first codeless solution for automating, integrating, and extending your private and hybrid cloud infrastructure. This webinar is being recorded and will be available on our blog. The link will be shared in a follow-up email within the next 24 hours. If you have any questions, please share them in the chat window. They will be answered at the end of the presentation. Without further ado, I present to you SovLabs Principal Architect, Sid Smith.
Good afternoon, everyone. So here we got some pretty exciting stuff to cover, but before we get into the really good stuff, we're going to give a little bit of history so everybody kind of understands the evolution of where we're at. So, but before we jump into that, why am I here talking to you for 60 minutes? And really it comes down to, I've been in this space for about 12 years, helping organizations with VRA since version 1.0. Worked with over 150 organizations to exceed success with their automation strategies. Historically, that looked a lot different than it looks now. Back many years ago, everything was done in a very custom-coded sort of way. But with SovLabs, we've been significantly helping customers reduce the amount of custom coding they have to do and making these automation strategies a lot easier. So it's been very interesting to see the evolution of how these things go. So what we're going to cover in the webinar today is the origins of SovLabs, the new SovLabs platform named OneFuse, the importance of optimization within your automation environment, and then also migrating to and adopting OneFuse in your automation strategy. And then we'll cover any questions and answers. So SovLabs has been making codeless integrations for VRA for quite a few years, almost 5 years or 6 years now. Historically, these integrations have been very specific to VRA itself, where all of these were a VRO plugin that were then consumed and managed from within VRA, and they were limited to consumption by workloads being deployed as part of the VRA lifecycle. What we've been working on for over a year now is taking these integrations that we've been helping customers implement for VRA and sort of breaking them out of their shell. Taking all of these integrations that historically, again, had to be consumed via this VRA lifecycle, and again, they were VRO workflows, and pulling them out into a net new platform. But one of the things that we refined along the way while we were working with customers and consuming these integrations within VRA was a data-driven approach that offers our customers a lot more flexibility in how they consume integrations, whether it be with VRA or, as you'll find out soon, something else. And so even with VRA, we found a lot of organizations didn't want to use the catalog. They liked the very prescribed lifecycle, its ability to integrate, and call those integrations throughout that lifecycle. However, some folks were using Servicenow to make requests into VRA. Some folks were using Ansible, Terraform providers, and other things, API calls straight into VRA for the request. And we've been able to significantly reduce the amount of complexity involved in doing that. And even if you're using the VRA catalog itself, this still applies. And what it really does is it extracts down from having to maintain a significantly large catalog of blueprints within VRA. Historically, we've seen organizations with anywhere from 300 to upwards of 800 blueprints in their VRA catalog. And as you can imagine, that becomes very, very challenging to manage over time as different things become completely consumed. Those blueprints require some maintenance to keep working. And the strategy that we've helped a lot of organizations with is doing this very dynamically and distilling down to really the bare number of blueprints that you would need in your VRA environment to make it much easier to manage. And so with that, just to give you kind of an example of what we're talking about here, when you ask a consumer questions or when you're taking that information in from your consumers, something like what environment is this going to be placed into? And they might choose something like production or development. That selection, within VRA itself, it literally just means production or development. It doesn't have any definition as to what that is. But with our modules, and most particularly something called our property toolkit, we give you the ability to actually define what those things mean, because production means something for all of your different integrations, and those things are different. It means one thing for naming, something else for network placement, and then your IPAM integration for your Active Directory, folder placement, tagging, all those different things. And just like development would mean different things as well. So allowing you to really define what these selections that your consumers are making, and use that to more dynamically drive the outcome of what's actually happening in your environment. And in doing that, as if we look at this slide and try to understand what it's trying to depict, is we can also have these things work together, right? Because it's not very often that you'll ask a single question and that's going to be all there is to it in your decision-making process. Your business logic usually is going to take into account a series of different things that you need to collect from your consumers. And what we've found over time is most organizations were custom coding that logic in things like VRO or Java code or whatever it might be. And now that business logic becomes very, very difficult to maintain. Well, with this data-driven approach, your business logic is really just nothing more than configuration and making decisions on how you want to proceed based on one or more factors and how they're going to impact the outcome of what gets deployed. So the same principles in what we've been doing in VRA with our embedded modules and helping organizations dynamically drive these environments and make them more standardized and more optimized, if you will, we've carried over into our new platform called OneFuse. And the OneFuse platform sits independent on its own, so it's not embedded inside of VRA at this point, and our modules now are within that platform. So when we take a look at this, right, we have our automation environments, which could be VRA environments, or it could be other things as well. Many companies are adopting Terraform and using Servicenow and CloudBolt and Ansible and all these other products, and those can now consume our OneFuse platform for all the integrations that we provide for automation. Now, the way we do this, if you're not familiar with our existing plugins, and the same methodology is what existed within the VRA product as well, is we leverage centralized policy management so that we can build all the standards, your automation use cases, and your business logic into a policy and use the metadata to drive those policies intelligently. Those policies define things like your naming standard, your different IPAM profiles, or your different networks that you might want to consume and all the information that go around them, and all the different things that you might need to consume various different integrations. How am I going to determine where to put something in AD for Active Directory integration? And what you end up consuming is the policy to leverage that integration, and that policy has all these things in it that tell us what we should be doing. And historically, again, those policies existed in our VRA plugin for 7, but today, now they're available for VRA 7, 8, Cloud, as well as Terraform. We have released a Terraform provider for that, for the new product, and there is a full REST API. So even if we don't have a pre-built integration for your automation solution, you can simply consume these integrations through the REST API as well. So what this allows us to do, and so this is kind of a distilled up. Blueprint is sort of a concept, although in VRA we call them blueprints, but some of the other products call them different things. But in the end, this allows you to really consolidate and standardize, not just across a single platform, but across multiples. Because if I was consuming a certain type of resource from VRA catalog, maybe it's a blueprint, and I can go in and say, I want a MySQL server, right? What does it look like to consume that MySQL? What is the end result that's going to be deployed? That's going to be oftentimes heavily dictated by your business logic, as well as the integrations that are involved in that deployment. When you think about the automation piece of VRA, it's creating the VM, but all the information that goes into that VM is really handled through the automation piece and a lot of the integrations involved. Well, now you can have that same concept, and if you have folks using Terraform, they can deploy something that's going to achieve the same outcome using the same set of business logic, taking in the same set of inputs, just using a separate product. So allowing you to really consolidate down the number of blueprints you have in your different systems that you're using and standardize across all of them so the experience becomes the same. So this evolved out of some of the challenges we had with being in an isolated environment. So historically it was VRA 7, but even if you start looking at this, and we have many organizations that are using other products than just VRA 7, using Terraform, some are starting to adopt VRA 8, and when you start to look at this, they're still going to have VRA 7 in the environment, and through all these different mechanisms, we use naming as an example, you run into the problems of managing these independently in each individual environment. You run the risk of generating the same name in this example, but having conflicts between those different platforms when doing these things. And then you have to maintain, again, this naming scenario in each one of these different platforms. And that problem becomes much greater compounded when we start adding on IPAM integrations and AD integrations and all the other things you may want in your environment. Maintaining them all independently across these platforms can be a daunting task and can lead to some challenging issues. And more often than not, a lot of organizations have multiple instances of VRA 7 or multiple orgs in VRA 8, different folks consuming Terraform in different ways and other different products throughout different segments of the organization, doing all of these things in bubbles. And so the benefits of using something like our OneFuse product and consuming our centralized policies is now all of these different solutions that need to consume these various integrations can do so from a centralized source and not have those conflicts, and also not require maintaining those integrations at each of these different endpoints. And especially when you start thinking about custom code and maintaining custom code at all of these different endpoints that you might be consuming from, that becomes a significant amount of management overhead. So we also you gain the ability to do things that you weren't able to do before, or it became more challenging to do. So in an example of naming, something like validation, right? I can now define validators in one place, define my naming policies in one place. And when any one of these different solutions go to consume that policy and a name gets generated, we can validate it against your defined validators, whether it's DNS or whatever it might be. And then and ensure that name's going to be unique. And these same concepts, again, apply to all the various different integrations that are provided as part of the OneFuse platform. So one of the things we see, working with customers is the number one thing that we really need to focus on before we start to adopt something like this is assess the current situation. We're getting a lot of requests around moving from VRA 7 to VRA 8, and the reality is VRA 7 is not going to go away from most organizations anytime soon. Even when moving to VRA 8, there's the issue of manage the workloads that are currently within VRA 7, and there's no way to migrate those to 8 as of today, and it looks like it's going to be quite some time before that becomes possible. So ideally, as part of that assessment, what we really want to be able to do is understand the current state of that VRA 7 environment. There's 5 critical areas that make up pretty much 85% of the migration overhead when it comes to VRA 7. And one of those is the number of blueprints that you have. The more blueprints you have, the more you have to replicate and move to another solution, whether that be VRA 8 or something else. And the more that we can reduce that number and drive things more dynamically, the easier it is going to be to migrate or adopt those on another platform. The second thing is the reservation architecture within VRA 7. The reservation architecture is a pretty old architecture. It's something that most folks have been wanting to move away from for some time because it's really allocation-based rather than consumption-based. But there's things that we can do within VRA 7 to make it somewhat more allocation-based so that it lines up better with other solutions that you might be adopting. And probably one of the biggest things is the custom code that's been developed within VRA 7 for the integrations that exist there. Having to move that custom code to a new platform is a very, very long, tedious, and challenging task. And then, of course, we still have the issue of VRA 7 not going away. Right? So they have to maintain that code not only in VRA 7 still, but possibly maintain a different version of that code in some other platform, whether it be, again, VRA 8 or something else. And then software components to perform script execution. If you are moving to VRA 8, those don't exist in 8, and it doesn't look like they're going to. So they're going to have to be retooled as well. And if you go to a different platform that may or may not have a solution, or you might be looking to move to something like Ansible or Puppet. So these are all, really, really critical things to really assess before we even think about doing that migration or adopting something else. And then the last one is the network architecture. Because network architecture itself, how we're consuming networking, how we're allocating IPs, what IPAM we're integrating into, what all there, whether it's external networks or if we're doing any kind of NSX type support, it is very important to get a good handle on and get that optimized as well. And then just analyze it for general design principles. And we do have a free optimization assessment that we do for customers that give them insight into what their current situation is when it comes to VRA 7, and also provide some guidance on how we can help optimize that environment using our modules. So the one key factor is reducing the management overhead, again, by reducing those blueprints up by up to 90% or more by driving them dynamically. Reservation optimization, so doing some reduction in the amount of reservations in the environment by up to 60%, the reduction in custom code, and whereas we most likely can't always eliminate custom code because a lot of organizations are doing things that may be even based on other custom in-house solutions or products that we just don't offer integration for today. But we find that typically we can reduce that code by 65% or more. And of course, if you can implement an industry standard configuration management solution, that would greatly help with being able to put your scripts in a place where they're going to be able to be consumed by more than just one platform. And then simplification of network profile management, as well as the business logic that goes into place when making decisions as to what network workloads should be placed on. So by doing this, it really helps you narrow your focus. As we're looking to move away from VRA 7, there's a couple of things that you really should be focused on, and using readily available codeless solutions wherever possible is going to help with that. And so any of those custom integrations that you still have a need for should really be focused on those CRUD operations. So we find often with VRO and VRA 7 that the integrations have more than just the necessary CRUD operations in them to interact with whatever endpoint they're communicating with. There's often a lot of business logic in there, and that becomes very cumbersome to maintain. So if we can pull that business logic out and make that more configuration-based, then your integrations are going to be a lot simpler to build for those ones that you still need to maintain. And you can be focused heavily on just those create, update, and delete operations that are required. So again, remove that business logic from the integrations and define that business logic as configurations. So looking to move away from VRA 7, one of the things that we've had a heavy focus on when it comes to the OneFuse platform and thinking about our existing modules for VRA is making it very, very easy for our consumers that are using our modules to port them over to the new OneFuse platform. And so we do have a migration tool that allows you to take those policies that you created for your naming, your IPAM, your AD, and whatever else it might be, and move those over to OneFuse. Now, if you have minimal policies, it's probably just as easy to create them new. But we find, especially when it comes to IPAM and networks, a lot of organizations have a lot of networks, so they might have a fair number of what we call network profiles that need to be moved over. But also, we're got organizations now that are still adopting our modules on 7 prior to going to 8, and that's part of that optimize before you migrate away. So get it adopted on 7, get to a standardized approach, and then move to VRA 8 or whatever platform you're moving to, so that your integration consumption remains consistent and standardized across the 2 platforms. And eventually, what ends up happening is, if we take a look at the traditional VRA 7 implementation with our embedded integrations, we have blueprints that are going to consume these integrations as part of that life cycle of the blueprint deployment. But then as they start to cut over to the OneFuse platform, we're able to cut them over one integration at a time. So there's no massive lift and shift that needs to be done as far as cutting all of these over at the same time. So your blueprints and your deployments in VRA 7 will keep functioning for your consumers as you're moving to your new platform, if that's going to be VRA 8 or whatever it might be. And one at a time, you can start to adopt the integrations as they become available in OneFuse until you're finally cut over. And on the VRA 7 side, nothing really looks any different, right? It's simply a flip or a switch of the EBS or even a property to make this change. And by the time it's all said and done, you're now consuming everything through the OneFuse platform. And so once VRA 7 is able to consume all of these integrations, then you can start consuming them from whatever other platforms that you may need to. There's some other benefits we get from doing this as well, and I'm actually going to move to a live demo at this point, so just bear with me for 1 second. I'm going to switch away from these slides. But the benefits are, you're no longer limited to just being able to invoke integrations as part of the provisioning event. So let me go ahead and share this out. So here you can see here is the OneFuse environment, and in its initial release, we have released naming with a lot of the other what we call foundational modules, which would be Microsoft, IPAM, Microsoft AD, IPAM, and a few others coming in, I believe, sometime in October. Don't quote me on that. It might be November, but I believe it's sometime in October, and then the others follow soon. But some of the things you gain from a platform in this sense is, if we go and just look at the naming one as an example, we have our policy here, which is very similar to the policy that exists in VRA 7 today. We have the naming policy and the naming sequence. It's in the embedded plugin. But we've added something here where we call naming validators, and it lets you to define what DNS endpoints you want to validate the naming against. And there's some additional validator types coming in the future as well, where you'll be able to validate not only against DNS, but say VRA 7, VRA 8, and other environments as well. But then we get to see and actually start to look at the managed names in the environment. This was something that just wasn't possible in VRA 7. Having an understanding of what's been happening with the integrations in the environment, what has been consumed, and how has it been consumed. And if we start to look at this now, every time a name gets generated, and this concept, again, transfers over to any of the integrations that we provide, we start to see, well, where did the request come from? So did it come from VRA 8? Did it come from Terraform Cobble or API call or VRA 7? Who requested it? What was the name that was generated, and what policy did they ask for? So now you have insights into what's happening in your environment from an integration perspective that you just didn't have before. And that insights don't stop there. So you get some information around what was the API call that was made for this request, what inputs were we given. So when we go back to that example of driving things dynamically, right? Here I'm passing in specific inputs for naming, but what you'll see as this evolves is I could be passing in this as a production environment. And within the platform itself, you can define what that effect is on naming and other things like that. But the important aspect here is that I can see what was sent into the platform that led to the result that was outputted. So that if the expected output wasn't something that I anticipated, I can understand, well, why did it end up this way? So I have complete ability to have that visibility into there. Some other things that we've put into the platform as well that become extremely helpful is the ability to take things like, I have this logic here that's going to determine my name. This is rather simple logic, and some naming conventions require other things like potentially if statements and stuff like that to be involved in them, which makes them sort of challenging the test, because usually it's, let me request a machine, choose this set of inputs, see what the outcome is. And then let me request it again with a completely different set of inputs and see what the output is, until you've exhausted all of those possibilities. Well, what we've done in the platform, and again, this holds true for everything within the OneFuse platform, is we allow you to define something called active static property sets. And you create these static property sets within the interface, and then you can assign one as the active one. So here I've got one that's got a bunch of, we'll say, like mock inputs, and where I can say, if these were the inputs that I received as part of a request, what would the outcome look like? And we'll translate that for you in the interface to show you this is what the name generated would look like. Of course, if you go and just simply change to a different active static property set, by P for production, flip to a D for development, and you get a real-time sense of, is this giving me the anticipated result that I was looking for? You can test all your various inputs and combinations thereof to make sure that your outcome is what you'd expect it to be. And you'll notice here that we've got the curly brackets here. Anywhere we see those, we can use that template language within the interface. And anywhere we define that template language in the interface, you'll see that little eyeball. And then we're able to translate that using whatever the active property set is in the interface. The OneFuse platform was also built API first. So everything that we can do in the interface, you can do through the API, which is very nice, especially from a consumption perspective, because now you can consume your integrations from platforms that we don't necessarily have an out-of-the-box plugin for consumption. The other thing you can do, if you may have, let me cancel out of here, you may have noticed, is you can still define what those sources are. So here, I've got an API call coming in from Postman. I put my name on there. So I can define what it is. So if I need to call integrations from Jenkins or something else, I'm not left with it just being listed as an API interaction. I can define exactly what that endpoint is to something that's meaningful that I can now track and understand. The integration, if we go and look at my 7 environment, and we start to look at, kind of that story that I was telling earlier, where, we start working with customers and we see catalogs that traditionally look something like this, where there's many different blueprints. Sometimes they're very, very similar with minor changes, but all these blueprints need to be maintained and managed by somebody in the organization. To getting to more of an approach where we get to that optimized solution, and in this case, a single tier blueprint, where I can start to drive things very dynamically in the environment and consume codeless integrations. And here's a pretty simple example where I'm only choosing a very small handful of different things, and that's going to determine the outcome of what gets deployed. But the interesting thing you might notice here is I've got Windows and Linux commingled. I got different apps that rely on those different operating systems. And even if I choose Windows, I can do things like, well, what version do I want? And these are things that are typically challenging to do in VRA alone. But with the embedded modules, our VRA modules that we have, our integrations, you're able to get to this type of solution. And so this is the types of things we've been doing with customers for a pretty significant amount of time over the last 2+ years, helping them get to this very dynamic type driven approach where I can have the very few number of blueprints. I can ask the right questions that I need, and it's going to dictate the outcome of what needs to happen. However, this blueprint is using our legacy plugin that goes in the VRA, and it's consuming all of the integrations associated with it. And to make the change, so example, for naming, right, when I want to make that change, I have basically the same exact blueprint here. When you go in, the look and feel of it, exactly no different than the original blueprint, but there's one minor change that was made to move from our embedded naming to the OneFuse naming. And it was very simply just taking that single tier blueprint, which has a custom property defined. Actually, in this case, we're using a property group that contains the property to tell us what naming standard to use. And in the new version of the blueprint that I have here, which I could have done it to the existing one, but I wouldn't have that to show, it basically just required us to, okay, get in there, to remove that property group and define a new property for the SovLabs OneFuse naming policy with the policy name. And so that's one way of making the switch. But if we have some organizations that have still potentially 20, 30 blueprints as opposed to their 700, that's not bad. But they may not want to go and update those properties on all 30 of them. So the other option is to just modify the EBS subscription and disable the embedded subscription for the embedded module. And on the EBS subscription for the OneFuse module, have it use the same custom property that was used for the previous one to trigger the execution. So you can change it in one place and have it affect everything. So there's a lot of options of how to easily make and flip from the embedded modules over to OneFuse. And once all those policies that were created on VRA 7, if VRA 7 was in use, are on the OneFuse platform, now they're all available for consumption from things like VRA 8, Terraform, Cloudbolt, and others. But one of the other things that becomes possible that just wasn't possible with the embedded modules, and we'll go over to VRA 8 here for a second, is you're no longer bound to consuming these integrations just for virtual machine deployments. So in my VRA 8 catalog, I also have a catalog item to just get a machine name. Maybe I want to name a physical machine and I need the name so I can just plug it in, or a piece of networking equipment, or one of the guys that I work with jokes around about, he's going to use this to randomly pick a name for his child that's going to be born. But the point is, it can be generating a name for whatever it is that you need to generate names for. And so now you have a simple catalog request to come in. You fill out or ask your consumers for the information relative to the type of name that's being requested. And they go ahead and say submit, and it's going to return that name. Now, you can have, again, multiple different catalog item types based on the type of machine that's being requested, or you can even use the interface based on some drop downs and dynamic choices there to customize it to whatever the name is, or the type of name that you're looking to have deployed. And all of that still, you can have multiple naming policies for different types of things if they don't all conform to one standard. So there's quite a bit of flexibility there. And although I'm doing a lot of examples with naming because that's what's available in the initial release of OneFuse, this all applies to the other modules that become available as well. So not only would you be able to offer up just naming as an option, but you might have the need for, say, the network team to come in and request not just naming, but a whole network package where they could make a request, and not only does it generate the name and go and reserve the IP address, but it puts it all in DNS form. So now all they need to do is apply that to whatever it is they're deploying on the network. So it opens up a lot more options. You're talking things like F5 load balancers on demand that don't have to have a deployment associated with them. If we need to deploy a new VIP or new pools and things like that, you'll be able to have those catalog items to do the same. So really extending integrations within our platform and the integrations that we provide out to whatever you want to consume them from. And on that note, I'm going to take a pause and see if we have any questions.
We do have one question. It says, when do you expect feature parity for OneFuse to current SovLabs product?
Great question. So complete feature parity, we're looking at Q2 of 2021, but you know, by the end of this year, our foundations modules, which is our you know, naming, IPAM, DNS, AD, and I'm not sure if notifications in there, but there is some other modules included in there as well. I just don't remember the entire list off the top of my head. Will be available by the end of this year. Q1 of next year, things like Ansible, F5, Servicenow, and then some of the outliers that just are modules that you know, aren't heavily adopted. You know, we do have support for 6 IPAM providers, so things like Microsoft IPAM and, you know, maybe even one of the other ones that aren't as widely used might be later in Q2. But yeah, we're looking at Q2 for that parity. And then, you know, there is platform enhancements happening along the way as well. So within the OneFuse platform itself, to give you a little bit of a kind of glimpse into what's happening there, we saw these static property sets that allow you to, you know, validate and test things in the interface. But we're also adding support for something that we call dynamic property sets. And what a dynamic property set would really give you the ability to do is, when you send a request to OneFuse, you might tell us, back to that example again, that the environment is production. And that's all you would need to tell us. And then you might have a dynamic property set that's named production. And within that dynamic property set, you might have definitions that say, okay, this is production, so it's going to affect naming this way. It's going to affect IPAM this way. It's going to affect AD in this sense. And so now you can start to define what those things mean in this platform and then wrap business logic around that, right? Where you might pull together different parts of those requests. Like if it's a production machine, it's going to be MySQL and it's got compliance of SOX or something like that. You might pull bits and parts of each one of those dynamic property sets together to formulate the data that you're going to pass into the module, and it's going to use that with your business logic to return a result. And that's really that's a really awesome feature, because now that business logic and the things that you're using to make the determinations become, you know, much more simplified for anybody who's consuming the integrations. Oh, I need a production WordPress server with no compliance, and we'll be able to interpret, you know, what that means for all the different various integrations and send back those responses. And that would be the case from wherever the request came from. There's also additional things happening with more insights becoming available into the environment as well. So being able to get more information and drill in on more data surrounding the requests that are coming in. We're adding support for multiple workspaces. So currently there's a single workspace in here, but once the multiple workspace support becomes available, now you can go to your networking team and say, hey, here's your workspace. Go ahead, create all the different, you know, IPAM profiles for the different networks. Oh, and by the way, if they manage the you know, F5s, that can be part of their workspaces. And they can create the profiles so that the subject matter experts themselves can create the profiles for the things within their domain, and now others can consume those based on appropriate permissioning as well. So workspaces will add quite a bit of security and compliance and governance to the environment as well. And there's quite a bit of other enhancements coming to the platform overall as well. And then from there, it would be to continue adding support for additional endpoints that we may not have today. That was kind of a lengthy answer, but Any other questions, Morgan?
Yep, we have one more. Where are the property sets or policies defined and maintained in VRA 8?
So the static property sets in our interface get created within our interface. If we start looking at outside of that, right, you would be maintaining those in VRA itself. So if I were, let me bring up Cloud Assembly. And so this is where the property toolkit, if you will, that I was just explaining, really is going to simplify doing this within VRA 8. Because if we look at where, how these things are done in 8 today, there's limited property support in 8 to begin with. But now you're in your blueprint, you're defining a lot of these things, right? So I'm defining different metadata and stuff that I've got to send through. You might even be doing some logic in here, but under properties, I've got logic in here that's going to be sent through. But the downside of doing this here inside of VRA 8 is it's contained within VRA 8, right? So if I'm able to not have to put this logic here and just send basic inputs to OneFuse, and I have this logic located in OneFuse as part of those dynamic property sets, now that logic is consumable by any platform I want. So if I've got people using VRA 8 and I got people using Terraform, I don't have to maintain this in 2 separate places, right? And of course, there's also limited, and I know this is being expanded, but at the moment, there's limited places to define your properties within VRA 8 today. So whereas, in this example, I've got some inputs that my consumers can choose, but then I also have some properties that I'm formulating some logic on that are being used to drive some of this stuff as well. But yeah, that's all part, here in the blueprint. There's a few areas within 8 where you can define properties outside of that, but nothing significant today. Any other questions, Morgan?
That appears to be all our questions. So if you have any, now's the time.
Yeah, I mean, if anybody wants to see anything around the Terraform integration, or bring up the API, if it's real quick. So the API, does have a Swagger interface, and so it's fully documented in here. You can come in and do tests on the API itself, through the Swagger interface, and it's very, very simple REST API with all of the same capabilities that are available in the UI. We haven't kept any aspects of the API hidden or reserved. You get access to it all. So as we continue to evolve and add more and the API grows, you'll have access to all of that as well. And then, if we think about something like Terraform real quick, I'll just cover it. I have 2 examples here, one of which is just Terraform asking for nothing more than a name. So my Terraform, my file is just going to go and ask for a name, and then another one where I'll actually just deploy a vSphere machine, and it'll get a name and apply that to the vSphere machine. But so it's a drop-in provider for Terraform, very, very simple to consume. If we take a quick look at the main.ts, I'll type that to last. Here, I'm just consuming the OneFuse provider. I do have some variables I'm taking in from a variables file, and not a whole lot really going on there. On the vSphere one, I'll just go there real quick. I'm doing the same thing, but whoops, something happened there. I piped it to less, I meant to cat it. All right. And I got caps on. Ain't gonna work. All right. So on the vSphere one, I'm consuming my naming integration from OneFuse, and then taking the response from that later on down the road, if I can find it easily here, and I'm passing it in as the name for the vSphere provider. The really cool thing about the way this is done is you could use it to name just about anything, and just about anything using any provider. I don't know where I passed it up here. So, it may not even, if you're deploying load balancers using a provider, you can name your VIPs, you can name your pools, you can name whatever it is you want to name, and you can call the naming module multiple times and have it generate using different naming profiles and things like that, and just really use it for whatever it needs to be. And the same thing with the IPAM module when that becomes available, if I need to IP my VIPs. So really, it's just how you want to consume it. You consume our module, it's going to give you a result. Where do you want to use that result? And so here we've got OneFuse naming, and we're just referencing the variable that's holding the name and the domain, and it's going to go ahead and pass that in to name that vSphere machine. And so again, the uses of these integrations becomes greatly expanded beyond just, I can have somebody request a machine out of a catalog and it's going to follow a predetermined script, and at the end result, it's going to consume these integrations. You can certainly still do that, and obviously most folks certainly still will, because that's one of the big benefits of using a CMP and automation, but you can use it in a lot of additional ways now as well, having your developers consume it from things like Terraform or whatever DevOps tools they're using, and if you have other tools in your environment that are doing things as well.
Do you have an example of a ServiceNow integration and deployment process?
For OneFuse, I do not. The ServiceNow integration for OneFuse will be available in Q1 of 2021. We do have ServiceNow modules for our 7.6 embedded plugins today, which is basically, there's two parts to it. One is CMDB, so from 7.6 to ServiceNow, pushing your CI records. The second module is called our connector module, which is to import blueprints from VRA to ServiceNow so that your consumers can make those requests against VRA. The design is still being done because we're looking to do some things that are going to offer a significant amount of more features and flexibility with the ServiceNow module for OneFuse. If we look historically, right, our ServiceNow module went from ServiceNow to VRA directly. The current proposal is that we're actually going to go to the OneFuse platform, and the OneFuse platform will be an intermediary to the blueprints that we'd be inputting. So then allowing you to actually interject things in the middle of that, giving you greater flexibility. But that, unfortunately, at this point is still in development and design, so I don't have a whole lot of details on it. Well, if there's no other questions, I think we'll give about 10 minutes of your day back.
Thank you all for attending our webinar, and thank you, Sid, for sharing. As I mentioned before, the recording will be available later on our blog and will be emailed to you as well. I hope you all have a wonderful day. Bye.
Thank you.